The lattice energy is the energy required to completely separate a mole of a solid ionic compound into its gaseous atoms. The lattice energy is difficult to determine directly from experiment. However, it can be calculated from other quantities that are known by taking advantage of a thermochemical cycle called the Haber cycle. Let's begin with a mole of solid sodium and half a mole of molecular chlorine gas. This gives us 1 mole each of sodium and chlorine atoms. Now we imagine that the sodium is sublimed to form a mole of gaseous sodium atoms. We also imagine the dissociation of the chlorine-chlorine bond in Cl2 to form a mole of gaseous chlorine atoms. The first process corresponds to the heat of sublimation of sodium, the second to the dissociation energy of molecular chlorine. Next, let us ionize the sodium atoms to form separated sodium ions and electrons. The energy of this process corresponds to the ionization energy of sodium. Addition of an electron to the chlorine atom corresponds to the electron affinity of chlorine. The lattice energy of sodium chloride is the negative of the energy released when a mole of solid sodium chloride is formed from the separated ions. We have experimental values for the 5 steps in the indirect path for formation of solid sodium chloride from the elements in their standard states. We can calculate the lattice energy by taking advantage of Hess's law, which states that the energy change in a process is the sum of the energy changes for the several steps that may make up a pathway for the process. The lattice energy calculated in this manner is 788 kilojoules per mole.